Hi viewers, this is a PSN Media Center. I am Mathan, Assistant Professor, Department of Mechanical Engineering, PSN Knowledge of Engineering and Technology, Tirunelveli, in Tamil Nadu. So now I discuss and I briefly explain about the real-time applications of refrigeration. First, the refrigeration. The refrigeration is a process of cooling substance to maintain the temperature as well as below that surrounding atmosphere. Next, refrigerator and heat pump. The refrigerator is a machine is to be cool some object, but the heat pump is a machine it to be heat of medium warm that is surrounding, because the refrigerator is regain the heat from the source, heat from the object, and heat pump is here to reject the heat from the pump. It is a flow chart of refrigerator and the heat pump. The heat pump to reject the heat to warm space, but the refrigerator to heat gain from the cool space. It is a heat pump and refrigerator. Some terminology of refrigerations. First of all, the refrigerating effect. It is defined as the quantity of the heat extracted from a cold body or space to be cool is given time. Like the refrigeration effect is the ratio of heat extracted from the cold space to time taken, and the specific heat of the water and the ice. Mostly the specific heat of the water, the value is 4.19 kilojoule per kilogram Kelvin, and ice is 2.1 kilojoule per kilogram Kelvin. It's a constant value for specific heat of water. What is mean specific heat water and ice? First, specific heat is a quantity of heat required to rise or below the temperature of 1 kg of water. It is a specific heat of water. Next, the capacity of refrigeration unit. The capacity of refrigeration machines were expressed by their cooling capacity. The standard unit used for expressions the capacity of refrigeration machine is ton of refrigeration. So, like 1 ton of refrigeration for heat extract from 0 degree. That is, the lateral heat of ice is 336 kilojoule per kilogram. It is a constant value for lateral heat of ice. What is a 1 ton of refrigeration? It is a quantity of water abstract to free C 1 ton of water. That is duration of 24 hours at 0 degrees Celsius. The major refrigeration is 300, latent heat is 336 kilojoule. Heat should be extracted from the 1 kg of water at 0 degrees Celsius to convert into the ice. To like some calculation of 1 ton of refrigeration. So 336 is the latent heat of the ice in 1000. It is a hours, 24 hours. So 336 into 1000 divided by 20 into 60. The 60 means it convert to the minutes. So finally, the 1 ton of refrigeration is 3.8889 kilojoule per second. Another some terminology of refrigeration is a coefficient of performance. So coefficient is nothing but the coefficient performance is nothing but the heat extract in the medium to the work input. So some system to gain the energy, then to release the some space, cool space. So finally, the coefficient of performance is the refrigeration effect to the work input, that is N divided by W. Next is a refrigerant. So refrigerant is a substance, that is the refrigeration means is a substance that is absorb heat This absorbs heat through expansion and evaporation process, and this losses heat to the condensation is refrigeration. The process called as refrigerant. The mostly some refrigeration are used for their real-time applications for air, ammonia, carbon dioxide, sulfuric dioxide, methyl chloride, methylene chloride. So most we are real-time application for our home or industries. Mostly we have used for the ammonia NH3 because it's a low cost, low maintenance, and efficiency is very good. Then the refrigerant. Already we discussed refrigeration. The refrigeration, there are two types of refrigerant. One is a primary, another is a secondary refrigerant. First, primary refrigerant, it is a working medium which used for cooling the substance by absorption of latent heat. For example, ammonia, carbon dioxide, sulfuric dioxide, for so latent heat is a form of the liquid sheet. So primary refrigerant full of refrigerant is have to liquid state, and the secondary refrigerant is a refrigerant. Secondary refrigerant is a substance already cooled by primary refrigerant and then employed for cooling purpose. Example, ice, solid carbon dioxide. So it is a sensible heat. So this kind of refrigerant is have to solid state. Then refrigerator. Type of refrigerator is ice refrigerator, air refrigerator, and vapor refrigerator. There are two types. First, ice refrigerator. The ice is kept in the ambient of refrigerator, and this acts as the refrigerating aids. It is a ice refrigerator. The air refrigerator is air is used for working agent. This type of refrigerator, like example of Bell, Colorado cycles, etc. Next is a vapor refrigerator. The working agent employed in this type of refrigerator are ammonia, carbon dioxide, So ice refrigerator is head of the cabinet. Air is refrigerator is using our air is working medium. Vapor refrigerator is working medium of ammonia and like carbon dioxide. Some application of refrigeration in chemical industries for separating and lubricating the gases, and manufacturing and storing ice. Is a preservation of perishable food item in cold storage. For cooling water, controlling humidity of air manufacturing, chilling the oil to remove wax in oil finery, and preservation of tablet and machines in paramedical industries, and prevention of fruit tissues for comfort air conditions in the hospital and the theatres, etc. And the properties of refrigeration. A good refrigerant should have high latent heat of vaporization. Already I told. And the latent heat is meaning of liquid refrigerant. Next, should have low boiling and low freezing point. Next, should be non-toxic and should not corrosive. Next, should be non-flammable and not explosive, and should have high thermal conductivity, easy to handle, and low specific volume of vapors, and last one is a high coefficient of performance. So these are the properties of refrigerations. You have to maintain and to obey this condition to good for refrigerant. Here is some layout of refrigeration system. Here there are 4 important components and 4 cycles there. First part is a compressor, second is a condenser, third is a expansion, fourth is a evaporator. So condenser and evaporator it is a heat exchanger behaviors, and the compressor to increase in pressure, temperature, etc. And the expansions is to reject the heat from the object. So okay, here it is a cycle for refrigeration. First here is a compressor. So the compressor will be produced for the high pressure, high temperature in vapor for the any one refrigerant. So refrigerant, there are different types of refrigerants there. Air, ammonia, carbon dioxide. So many refrigerants there. So if you want to like to any one refrigerant you have used. So I have used for the ammonia. So mostly is a real-time application we have used for the ammonia is a good refrigerant. Already I discussed. It's a low cost, high efficiencies and low maintenance. Here the refrigerant is a working substance, and the compressor is mainly used for to produce a high pressure, high temperature vapor for the refrigerant. This high pressure and high temperature and vapor is goes to the condenser. So condenser it is a heat exchanger media. It can be used to reduce the temperature, but there is no change of pressure. So the condenser is extract from low temperature, high pressure and liquid state of refrigerant. So next this condition is going to the expansion. Expansions mean to reduce the pressure. So here expansion, the release from the expansion to low pressure, low temperature and liquid. Then this condition is going to the evaporator. Evaporator, it is a one type of heat exchanger. It is operated after flow air. Then here it is a low pressure, then low temperature and liquids and evaporations for the evaporation. So this temperature is released from the system. Then this release from the evaporator to go to the again to compressor, low temperature, low pressure and vapor. So this process is a cycle to be continuous. It is a working of refrigeration. Here some cycle for the refrigeration. Here first one is a compression state 1 to 2 and 2 to 3 is a condenser and 3 to 4 is a expansion and 4 to 1 it is a evaporator. Here it is the graph from temperature and entropy. Here the cycle is 1 to 2, it is a compression. Already I told the compression is to produce of high temperature, high pressure and velocity. So here to increase the temperature and to increase the pressure and vapor. So the curve will be move on up. So 1 to 2 is a temperature increase. Then 2 to 3. So 2 to 3 is a condenser. Condenser already to explain. Condenser is to produce a high pressure and low temperature and vapor. So temperature is low, so the graph will be down. So temperature low and then entropy, that is to change as base. So energy, what is entropy means the energy transfer from one system to another system, one energy. So that is vapor is converted to the liquid. So there is a entropy in the change. So here 2 to 3 process, the low temperature, high pressure and the vapor is converted to the liquid. So next process 3 to 4. So 3 to 4 is a expansion mode. Expansion means already told. Expansion means only to change the pressure. So high pressure to convert to the low pressure. So there is no change of temperature and so less liquid same time to reduce the pressure. So 3 to 4 is a down of the entropy. Next 4 to 1. So 4 to 1 is a evaporator. Evaporator means the cooled refrigeration space. That is mean here is a low temperature. The temperature will be constant and here the entropy will be changed to liquid to vapors and low pressure to low pressure, low temperature to low temperature. But here the liquid will be converted to the vaporism. So this is the system will be cooled down. So this cycle is a repeater 1 to 2, 2 to 3, 3 to 4 and 4 to 1. It is a refrigeration cycle. Then here is we explain the vapor compression refrigeration system. It consists of vapor refrigeration compression refrigeration. The system consists of compressor, condenser, receiver tank and expansion valve and is evaporator. So here is addition of receiving tank is added to the vapor compression. So compressor, already I told compressor. The compressor reciprocating compressor generally used and a very big plant centrifugal. The compressor directly coupled with rotating engine. Here to produce a high pressure, high temperature and vapor. And compressor is a very big plant, already told, is a rotating engine, gas turbine used. Condenser. So condenser already discussed. Condenser to produce of low pressure, high pressure, low temperature and vapor to liquid to converter. So it is a coil of tube made of copper. And a receiver tank, it is a reservoir of liquid refrigerant. So the refrigerant tank to collect from the condenser. And expansion valve. So expansion is a throttle valve. High pressure refrigerant is made to flow at controlled rate through this valve. So expansion to convert to high pressure to low pressure. Evaporator. Evaporator is actually cooler and kept in the space to be cooled. Evaporator is cooled coil of tubes made of copper. So here is a low temperature, low pressure and liquid to vapors to the heat reject from the cool space. It is the same layout of vapor compression refrigeration system. It is a compressor, condenser, expansion, evaporators. So here same process of refrigeration, but here the adding of one parts is a receiver tank. The working of vapor compression refrigeration is the low pressure refrigerant vapor coming out of the evaporator flow into the compressor. The compressor is driven by the primary mover. The compressor is refrigerant vapor is compressed. So the high pressure refrigerant vapor from the compressor is then passed through the condenser. The refrigerant gives out the heat it has taken into the evaporator. The heat equivalent of work done on it on the compressor. The heat is carried by condenser medium which may be air or water. The high pressure liquid refrigerant then enter the expansion valve. This valve allows the high pressure liquid refrigerant to flow at the controlled rate into the evaporator. While passing this valve, the liquid rapidly evaporator. The most of the refrigerant is evaporated only in the evaporator at a low pressure. The evaporator, the liquid refrigerant absorb it later heat of evaporation from the material which is to be cooled. Thus a refrigerating effect is obtained. Then the low pressure refrigerant enter the compressor and the cycle is repeated. So here the system combustion process of vapor compression cycle is eliminated. Instead of that, the following three processes are carried out. One is absorbing ammonia vapor into water. Second is pumping this solution to be a high pressure cycle. Third is reducing ammonia vapor from ammonia solution by heating. This is a vapor absorption refrigeration system. Constructions. It is have absorption system consists of condenser, expansion valve, and evaporator. This performance some as they do in vapor compression method. In addition to this system has absorbed a heat exchanger and analysis and rectifier. In working of vapor absorption system is working, the dry ammonia vapor at low pressure pass into the absorber from the evaporator. In the absorber, the dry ammonia vapor is dissolved in cool water and a strong solution of ammonia is formed. Then heat evolved during the absorption of ammonia is removed by the circulating cool water through coil tube in the absorber. Then the high concentrate ammonia in the pumped by the pumping to generator through the heat exchanger. So the heat exchanger strong ammonia solution is heated by the hot weak solutions returned from the generator to the absorber. The generator of the warm solutions is further heated by the steam coil. The gas or electricity, then this ammonia vapor is driven by the solution. The boiling point of ammonia is less than that of water. Hence, the vapor leaving the generator are mainly of ammonia. The weak ammonia solution is left in the generator is called as weak aqua. This weak aqua solution is returned to the absorber through the heat exchanger. So ammonia vapor leaving the generator may contain some water vapor. So this water vapor is allowed to the condensation and expansion valve may be freezing resulting in chocolate. Finally, the analysis that rectify the incorrect relative in the system before condenser. The ammonia vapor from the generators passing through the series of tray in the analyzer and ammonia is separated from the water vapor. The separating water vapor returned to the generator. Generator means is compressor. Then ammonia vapor passing through the rectifier. The rectifier reassembled to condenser and the water vapor till present in ammonia vapor condenser. Then condensate is returned to analyzer. Pure ammonia vapor then passes through the condenser. The later heat of ammonia vapor is rejected to cooling water circulate through the condenser and ammonia vapor is condensed to liquid ammonia. The high pressure liquid ammonia is through tilt by the expansion valve and throttle valve. To reduce the high temperature of the liquid ammonia to low value and liquid ammonia partly evaporated. Then this led to be the evaporator. In the evaporator, the liquid fully vaporized. The latent heat of evaporation is obtained from flame and other body which is being cooled. The low pressure ammonia vapor leaving the evaporator again enter the absorber and then cycle is completed. This cycle is repeated again to provide the refrigerating effect. So here some application of refrigeration system. Already I discussed the application of refrigeration. Again I tell about application of refrigeration system. It's a preservation of medicine, preservation of fruit diseases and cooling drinks, chemicals, water and air conditions for industrials and dairy product. Mostly in the refrigerations we have used for the preservations of food, medicines and chemical, etc. And it's the main comparison of vapor compression system, vapor absorption system. Some kind of combination of some comparison statement of vapor and absorption system. So here the system for the vapor compressor system have more wear and tear and produce more noise, but absorption, removing the part in the system, is aqua hence the operation and less wear and tear. Here electrical power is needed to be drive the system, and here based on excess viscosity may be used. COP is more, COP is more, and coefficient of performance is more, is less. Then partial load performance is poor. Here is a partial load performance is not affected. Mechanical energy is supplied to compressor. Here heat energy is released. Here energy supply is off and 1/4 and off of the refrigeration effect, less it is about. And it's a change of refrigerating to the system is easy, it is a difficult. And the vapor is a difficult, compressor is easy. And the compressor preventive measure is needed, since liquid refrigerant accumulated in the cylinder may danger to the cylinder. It is a not bad effect on the system for the absorption system. Here some domestic applications of refrigerator. Here is our fridge. It is a real-time applications. Here there are 4 components there. One is a compressor, one is a condenser, one is a expansion, last one is a evaporator. Here we are using for the refrigerant for the ammonia, because it's a low cost, low maintenance and good efficiency. First of all, the compressor to produce some high pressure, high temperature and vapor to the compressor from the refrigerant. So this high pressure, high temperature and vapor is going to the condenser. The condenser is a cooling medium, is a heat exchanger. So this condenser to convert to the high pressure, low temperature and vapor to liquid form. That is entropy totally change. Here this entropy this conditions is going to the expansion. Expansion to only to have to reduce the pressure. So low pressure, low temperature and liquid state of releasing from the expansion. The expansions is going to the next evaporator. So evaporator is a low temperature, low pressure and low and liquid vapors. The entropy will be totally changed. So this form of the cooling. So fridge totally have to cool on the closing system. In case the system is not closed, the heat is not rejected. It is only for heating of the object. So next one is important for temperature control. So the temperature control to be connected to the evaporator. So if you want to increase of the cooling of the object, so the temperature control may be used. So if you want to do more cooling, so more amount of work is be done by the compressor, then release of the heat and absorb of the service is not release, it is absorb of the heat. Here is the fridge. Here already told is compressor, condenser and the evaporator and the expansion. So it is a refrigerant, ammonia refrigerant we have used for the fridge. So already I told of the cycle of refrigeration. Here household refrigerator used vapor compression cycle. So mostly of the real-time applications are our home fridges is a vapor compression cycle may be used, because it's a less energy. that is due to small and high efficiency motor and compressor, better insulation material, large coil surface area, better door seal. And the design of main freezer section minus 80 degrees Celsius, refrigeration section at 3 degrees Celsius. And the insulation material, so many insulation materials there, so particularly the refrigerator or fridge we used for the fiberglass and urethane foam. So mostly used for this material, and that is the fiberglass thermal conductivity is a 0.032 watt per meter degree Celsius, and foam is thermal conductivity 0.019 watt per meter degree Celsius. And the better work output to the evaporator of 43 degrees Celsius. In the ice maker 2 to 3 kg per day. The vapor consumption more effective and less efficiency. The vapor expansion is more expansive and less efficiency. And energy consumption, another factor of refrigerator. One is open the refrigeration door fewest time possible, cool the hot food to room temperature, clean the condenser coil behind the refrigerator, check the door gasket of air leak, and avoid unnecessary low temperature setting, avoid excessive ice buildup, and use the power saver switches. Don't block the airflow pass to and from the condenser oil. This factor is not effect of energy consumptions. So this you have to kind of saving of energy of refrigerator of energy.